Hello, welcome to Pre-Technical Mathematics. This video lecture is on adding and subtracting vectors, Chapter 8, Section 2. We'll get started with a few rules on how to do this. When we're adding vectors, we're first going to resolve all of the vectors into horizontal and vertical components. That's x and y. Then we're going to add all the horizontals together. We're going to add all the verticals together, and then we're going to use the resultant of the horizontals, or x's, and the resultant of the y's, or the verticals, to get a resultant magnitude and a resultant angle. Sound complicated? Let's go for it. Okay, here's our first one. Now, what we've got is angle A at 90 degrees. So this is at 90 degrees, and it's 14.3. Now angle B is also at 90 degrees, and it's at 7.2. So we don't really have any horizontal components to add, but we can add the vertical components. So our R will equal 14.3 plus 7.2, which equals 21.5, and our angle is 90 degrees. Now we're going to start getting into angles that are not perpendicular and horizontal so that we can start changing into components. Let's see where we go. Okay. This is still similar. We have angle C, which is, that's not right. 270 degrees is down, isn't it? It's straight down. Okay, so we had C at 65 going straight down 270 degrees. If we put kind of a grid system in here, we can see that this is 270 degrees. Then we have D, and D is 180 degrees. So that's going to be right here, and that's 72 and 180 degrees. Alright? Now, what we have to do is find our resultant, which is going to be right in here. Okay, so to find our resultant, we can use the Pythagorean theorem. R equals 72 squared plus 65 squared, and we end up with R equaling 97. So that is the magnitude. Now we have to find theta, and that would be this theta right here. It always comes from the x-axis. So I'm going to transpose this a little bit to try and make it more clear. This 65 was on the vertical component. The same vertical component is over here. We can transpose that without bothering it. Now we can see we have the opposite over the adjacent of theta. So that would be tan, wouldn't it? Okay, we use our inverse tan, and we want the opposite, which would be 65. You could remember that as also the vertical component over the horizontal component, and we should end up with 42.08 degrees. Now that's this angle here. Our actual angle from our 0, 0 point, we have to add 180. So we'll put down that it's in quad 3. This is quad 3. So we need to take 180 degrees plus 42.08 degrees, and that is our actual angle for theta r. Should be 222.08 degrees. Okay. Alright, here's an x value and a y value, and we're to determine the magnitude and the angle. So let's see. We have by equaling 520, and we have bx equaling 231. And we want to find the resultant of these two components. We can use the Pythagorean theorem. 520 squared plus 231 squared, and that should give us r equal to 569. Alright, now all we have to do is find theta. The theta we will find will be in here to the x-axis. We'll call that theta b. We're going to use the tan minus 1, and the vertical, or the y value, over the x value. And we should get theta b equal to 66.05 degrees. Now, both those numbers were positive, so it was in the first quadrant. So we don't need to worry about adding or subtracting from 180 or any of those items. We have one in the first quadrant. Alright, here's one for you to try. One thing, we've got an E here and F here. This actually should be an F. We want the terms to be the same, Fx and Fy. Sorry about that. let's see what we're getting into now. We've got two vectors at different angles and different magnitudes. Now let's just start out with a little sketch, okay? 75 degrees. That would be C equal to 12. And D is at 37 degrees. And that is equal to 15. Now each one of these vectors has an x value and a y value. D has an x value and a y value. If we take the x value of both and add them together, we will come up with a resultant x value. And then if we take the y values and add them together, we will come up with a resultant y value. We can then use that in the Pythagorean theorem, just like we did before. Now, I'm going to attempt to show you a little tip that may help you. We put some labels, horizontal, which is x, and vertical, which is y. Okay. First we have our vector C. The horizontal would be 12 cosine 75 degrees. And if I work that out, I get 3.106. Now the vertical value would be 12 sine 75 degrees. And that would equal 11.591. Both are positive, that makes sense. They're in the first quadrant. All right, let's analyze D. So we have vector D. We have the magnitude, cosine, our new angle, which was 37 degrees, and that equals 11.98. And then our vertical component is again 15 sine 37 degrees. And that equals 9.027. Okay, so we have our horizontals and our verticals. What we want to do now, this is our Rx value. We add them together and we should get 15.08. And we take our y values and we add them together. If they're negative, be sure to add negatives or positives. Carry your negative and positives down to the R value. In this case, we're working all in quadrant 1, so all our values are positive. Okay, so what we have now is we have our y equaling 20.6 and our x equaling 15.1, and we want to find the new resultant. So I'm running out of room here. Our Pythagorean theorem, 15.1 squared plus 20.6 squared should give us the magnitude of 25.55 remember our theta equaled the tan minus 1 over the y value, 20.6, over the x value, 15.1. And that should give us 53.8 degrees. So our answer is 53.8 degrees, and R is 25.55. This little chart is going to take a little bit of time to make, but it does make your life simpler. Let's see if I've got another one for you. No. That's not what we want. We don't want to go backwards, right? Ah, here's one. Boy, does this look complicated. Okay, first we have to discuss the error I've made in the slide. This should be 45 seconds, or 45 minutes, and 196.12 minutes. Now when we have minutes, what we need to do is change that into a decimal degree. So what we do, there is 60 minutes in a degree. So when you add that up, it should end up as 262.75 degrees. And this should be 12 minutes out of 60, so that should end up 196.2 degrees. Alright, let's start our chart. Vector, x component, y component, we'll start with C. We have the value of C, 79.63. Cosine, and as long as you always use the full degree from the 0, 0 point, you can always use cosine. So we'll put in here 262.75 degrees, and that will equal a negative 10.049. It's negative, notice. Well, where is 262? In the third quadrant. The x is negative. The y should be negative too. Let's see, 79.63. Sine of 262.75 equals negative 78.9. Alright, the D vector. We have a new magnitude, 43.72. Cosine again, and this time we've got 196, what do we say it was, 0.2 degrees. That should equal negative 41.98. Let's see, 196, that's also in the third quadrant. So they're going to be negative. Both of them again are going to be negative. So let's complete our y component. Negative 12.197. Okay. We have our y equaling negative 91.190, and our x equaling negative 52.03. R equals the Pythagorean theorem. Now it won't matter the negative signs, because as you square them, the negative sign goes away. So R should equal 104.99. We could say 105. And we find theta R equals 10 minus 1 of y, negative. Now in this case, make sure you use the negative numbers. It will come out totally different if you drop those negatives. 52.03. And what we come up with is 104. I'm sorry, it wouldn't be 104, would it? It's got to be in the third quadrant. 240.3 degrees. Okay, what does that mean? That means our Rx is negative 52.03. Our Ry is negative 91.19. And here's our resultant. It is in the third quadrant. So this would be the 240.3, and the magnitude was what? About 105. Okay? That makes sense. Both our x component and our y component are both negative. Belongs in the third quadrant. These will take you a little extra work. Here's one for you. Now notice in this case, you have one in the first quadrant and one in the second quadrant. So you'll be working with negatives and positives. Be sure to keep your negatives and positives in that little chart so that you don't lose them. Check your answers with the course information. This is the end of this lecture.